Hello. Welcome, everyone. Thanks for being here. And to get started, I'd like to get a feeling for the knowledge of the audience. So I will show you a little poll. So you should be seeing, yes. You are seeing 4 items. And what I'd like to know is, what is your level of knowledge? Do you have understanding of OOP in any language, which you should in order to fully understand this webcast? Have you worked with single objects in JavaScript? Have you used constructors in JavaScript? And have you worked with prototype chains in JavaScript? So multiple selections are possible. So please check whatever is appropriate and submit it now. And I'll give you a little time to fill it out. And then I will show the poll results. All right. So 95% of the audience has an understanding of OOP. I'll try to explain everything as well, as slowly and as detailed as I can. 78% of you have worked with single objects. 70% of you have used constructors, and 30% have worked with prototype chains. So everyone will learn something today, which is good. Let's get started with the actual presentation. We will now. So what you will learn about is JavaScript OOP. And I think the best way to understand it is to learn it incrementally. And each of those increments I present today, I call a layer. And each of the layer only depends on prior layers. So it allows you to learn everything step by step. The first layer here is a single object, and most of you have used single objects. Afterwards, I will move on to something that is traditionally considered an advanced topic, but I think it makes it easier to understand the later content, and that is prototype chains. So prototype chains is about creating chains of objects via the so-called prototype relationship. The third layer is the constructors, and constructors are factories for instances. They set up objects. And the fourth layer is an advanced topic, and this one is about how you can derive a subconstructor from a superconstructor. Let's get started with layer 1, single objects. In JavaScript, objects are the atomic building blocks of object-oriented programming. And basically, they are maps from strings to values. And the entries in these maps are called properties. Methods are simply properties whose values are functions, so they are not that special. And inside a method, you can use the special variable this to refer to the so-called receiver of the call, and we'll see an example of that in a moment. So this down here is how you create an object in JavaScript via so-called object literal. We are creating an object and putting it into the variable called Jane. And this object has two properties. One property whose key is name, whose value is the string Jane, and another property described, which is a method because its value is a function. And you can see down here that what this method does is it returns a value and it accesses one of the properties of this object. And the receiver, which this refers to, is simply the object on which a method has been invoked. So let's look at an example. So this is the object we've just seen, and once we've created it, we can access it. So we can access Jane name, and it gives us back the value of the property name. Hello, welcome everyone. Thanks for being here. And to get started, I'd like to get a feeling for the knowledge of the audience. So I will show you a little poll. So you should be seeing, yes. You are seeing 4 items. And what I'd like to know is, what is your level of knowledge? Do you have understanding of OOP in any language, which you should in order to fully understand this webcast? Have you worked with single objects in JavaScript? Have you used constructors in JavaScript? And have you worked with prototype chains in JavaScript? So multiple selections are possible. So please check whatever is appropriate and submit it now. And I'll give you a little time to fill it out, and then I will show the poll results. All right, so 95% of the audience has an understanding of OOP. I'll try to explain everything as well, as slowly and as detailed as I can. 78% of you have worked with single objects. 70% of you have used constructors, and 30% have worked with prototype chains. So everyone will learn something today, which is good. Let's get started with the actual presentation. So you will know. So what you will learn about is JavaScript OOP. And I think the best way to understand it is to learn it incrementally. And each of those increments I present today, I call a layer. And each of the layer only depends on prior layers. So it allows you to learn everything step by step. The first layer here is a single object, and most of you have used single objects. Afterwards, I will move on to something that is traditionally considered an advanced topic, but I think it makes it easier to understand the later content, and that is prototype chains. So prototype chains is about creating chains of objects via the so-called prototype relationship. The third layer is the constructors, and constructors are factories for instances. They set up objects. And the fourth layer is an advanced topic, and this one is about how you can derive a subconstructor from a superconstructor. Let's get started with layer 1, single objects. in JavaScript, objects are the atomic building blocks of object-oriented programming. And basically, they are maps from strings to values. And the entries in these maps are called properties. Methods are simply properties whose values are functions, so they are not that special. And inside a method, you can use the special variable this to refer to the so-called receiver of the call, and we'll see an example of that in a moment. So this down here is how you create an object in JavaScript via a so-called object literal. We are creating an object and putting it into the variable called Jane. And this object has two properties. One property whose key is name, whose value is the string Jane, and another property describe, which is a method because its value is a function. And you can see down here that what this method does is it returns a value and it accesses one of the properties of this object. And the receiver, which this refers to, is simply the object on which a method has been invoked. So let's look at an example. So this is the object we've just seen, and once we've created it, we can access it. So we can access Jane name, and it gives us back the value of the property name. We can also access Jane.describe, and we find out that the value of that property is a function. So describe is a method, and now we've just retrieved its value. If we want to actually call it, we do the following. We append parentheses. And then the method returns the value as we've seen here, and we can see that, I will increase the font size a little, and we can see that the receiver in this case is Jane, which is why this.name accesses the property name of the object Jane. And a big advantage of JavaScript is that you can create objects directly in this manner. So many other object-oriented languages can't do that. But because JavaScript can, you can create objects directly and introduce abstractions later. So that makes it really easy to prototype and to explore interactively before introducing abstractions later. And you may think that objects are only maps because the syntax you use to create objects in JavaScript is very similar to how other programming languages create actual maps, but they are more. They are similar to maps in that they are very dynamic, much more or more dynamic than in most object-oriented programming languages, because you can freely delete and add properties. On the other hand, they are more than maps because you have inheritance and you get quick access to properties if you use constructors and adhere to certain rules if you don't add or remove properties after you've constructed an object. So that concludes layer 1. Layer 2 is about prototype chains. And the problem that you're trying to solve with prototype chains is that you want to share data. And here's an example of where objects contain redundant data. You have two objects, one is Jane, the other one is Tarzan, and each of these objects has individual data that is specific to the instance, namely the property name. And in Jane, in the object Jane, it's Jane. In the object Tarzan, it's Tarzan. But on the other hand, they both have the same method described, and that is redundant. We'd like to share this between those two objects. And the way to do it, and here's a diagram. The way to do that is by giving the instances Jane and Tarzan a single shared prototype. So Jane has a prototype, Tarzan has a prototype, and they share the same prototype, and because of that sharing, describe only exists once and is not redundant anymore. And the nice thing about such a prototype chain is that the prototype chain still seems to be a single object. So if we look at some demo code, then we can see now Jane is actually split up into two objects because kind of its extension where it continues is person proto, as indicated by this special property underscore underscore proto underscore underscore. So the way to pronounce that property is dunder proto, for double under, for double underscore. And so it's actually split in two, but it still seems to be the same Jane that we've worked before. So what you can do is you can ask for the name. You can also ask for the value of describe, which is still a function. But you also can even call the method up there in the prototype. And then it works perfectly. And the reason why it works is that this up here still refers to the receiver. So this does not refer to person proto, because otherwise it wouldn't find the value of name. This refers to Jane, the receiver of this method call. And that's why the method is found up here in the prototype, but when it uses this, it still can find name down here, which is cool. And if we access describe directly, not via Jane, person proto, then you see that it can find name, and whenever JavaScript has a property that it doesn't know, or you try to read it, so if I access Jane who, you always get back the value undefined. And that's what happened here. The receiver was person proto, and this .name didn't find a property, which is why the result up here was undefined. But if we call describe via Jane, everything works perfectly. And now for the next slide. The special property dunder proto that we've used so far is not yet a standard. Many browsers support it, but not all of them. And if you want to be 100% compliant with ECMAScript 5, you need to use a different mechanism. And there are two methods that allow you to do that. The one is object create. The other one is object get prototype of. And the way object create works is, and I'm simplifying, you can do more, but I'm showing it in its simpler mode, if you will. It has a single parameter, and it creates a fresh, new, empty object whose prototype is proto. So this is an example of creating Jane in the same manner as we did before. Differently, we create it differently, but the result is the same. So here we again have the prototype, and then we use object create to create a fresh object whose prototype is person proto. And afterwards, we can use it like before. And if you want to read the prototype of an object, you use object get prototype of. And down here, if you ask, is the prototype of Jane, is it person proto, JavaScript will say, yes, it is. The third layer is constructors. And let's start with something simple. We've seen Jane and we've seen Tarzan, and we'd like to create, well, some kind of factory for this kind of object. We'd like to create a constructor for persons. And the way you do that is you create a normal function, but you don't invoke it via a function call. You invoke it via the new operator. So functions play several roles. One of the roles in JavaScript is a normal function that you call, and another role is constructor. And the new operator enables the role constructor. And what the new operator does is it creates a fresh new object. It calls this function, and it sets the value, it sets this to the freshly created object. And that enables the constructor to then set up the freshly created object. And afterwards, the new operator returns the freshly created object. And what we've done here, we're setting up a new object, and we give it two properties as before. One property name, which is equal to the parameter that has been provided, and another property describe, which is a method. And let's try that out interactively. This is the constructor we've seen. And we can, again, create a new object, this time by using the new operator. And then we can see that describe works as before. Jane is also a name. And we can check out what properties are in Jane via the method object.keys. And we find that it has two properties. And the instances we are creating via that constructor therefore look like this. Jane had the two properties name and describe inside the instance object, inside the very first object in a prototype chain, as we'll see in a second. So this, and the same thing with Tarzan. It has two properties. And again, we have a redundancy that we would like to eliminate. And constructors allow us to do that too. And you do so via the object person.prototype, and the prototype property of every constructor holds an object. And into that object, we are putting whatever needs to be shared. So here we're saying the instance-specific data is the name, and the stuff that should be shared, or the single property that should be shared, is describe. And, well, let's try it out first. And see what happens. We create chain like we did before. Chain has a name. But now we find that if we check what property keys exist in chain, hang on. So if we create chain again and check for the keys, then we find that the instance only has a single property. And now we can check the keys of the prototype of chain. And we find that it has the describe method as assigned up here. And therefore you have a nice separation of concerns. You set up the instance-specific data up here, and you add everything that you want to share to person.prototype. And the structure that is created in memory looks like this. So what you have here is the constructor person. It has its own property, and the property is called prototype. And the value of that property is an object with the shared properties, with the methods. And all the instances that the constructor person creates, if you invoke it via the new operator, those look like down here. And they only have the name property, which has been assigned in the constructor function. And the remaining properties are up in the prototype. And a problem that often confuses beginners is that the terminology of JavaScript is unfortunately overloaded in this area. So you have two prototypes. The first prototype is simply the prototype relationship between objects, and the second prototype is a property that all constructors have. So we can see that up here. On one hand, the function person has a property whose name is prototype, And on the other hand, you have the prototype relationship between the instances and this object up here. So we can say that person.prototype, the object in person.prototype, becomes the prototype of all instances. And this is where it kind of comes together, where the overloading kind of makes sense. And usually the context makes it clear which of the two prototypes is meant. If you want to disambiguate, then you can call the prototype number 2, you can call that an instance prototype. So this up here is an instance prototype if I refer to it via person, and it's simply the prototype of these objects if I look at them from Jane or Tarzan. And last, we have the instance of operator. Let's look at that one really quickly. We have created Jane, and we can check that Jane has been created by person, and it returns true. The question is, how does the instance of operator make that check? How does it determine that? And it does that by checking whether, so if you have a constructor, if you execute value instance of constructor, it performs that check by checking whether constructor.prototype is in the prototype chain of value. That means that these two expressions are equivalent. So you can either say value instance of construct, or you can check construct prototype is prototype of value. Layer 4 is advanced and a bit more complicated. The thing is that JavaScript is usually flexible enough that you don't need inheritance between constructors as often as you need in other languages. So, what are we trying to achieve if we say inheritance between constructors? This is an example of a constructor person, and we'd like to create a new constructor called employee that is derived from person. That is, employee should mostly be like person, but it should do a little more and it should work a little differently. And what person does, it's almost the same constructor that we've seen before. The only thing that is new is this method here where you can say hello to, and you specify a name, and then it logs a message on the console, and whoever that person is says hello to whatever the value in the parameter is. And describe it as before. What we would like our constructor employee to be is we want it to have an additional instance property called title, and that property should be initialized via a parameter, a second parameter, which is like additional compared to person that this constructor has, and then describe should also work differently. We want to override describe, and it should do initially the same that describe of person does, but we also want to append the title of a person afterwards. So what we need to do is employee must inherit all the instance properties of person. It additionally must create its own instance property title. So that's the instance part. And the prototype part is person needs to inherit all of, employee needs to inherit all of person's prototype properties, and it needs to override the method describe of person. Additionally, it needs to call the method that it has overridden, the so-called supercall. So this is how we do that. Again, employee is just a function. And the first thing we do is we call the superconstructor person, and we hand over to person the current instance, which is in this, and which is an instance of employee. And that gives person the opportunity to add its instance property name, because it's not called as a constructor, it's called as a function, but we set the value of this to the current instance, to the instance of employee. After person has added its properties, employee adds its own properties. And in this case, it's a single property, it's title. And the value comes from the parameter. When it comes to the prototype, it's a little bit simpler because all we need to do in order to inherit the prototype properties of person is to make the object that is in employee.prototype and prototype P of person.prototype. So we create an object, a fresh one, whose prototype is person.prototype, and we assign it to employee.prototype. And then, thanks to the prototype chain, we automatically inherit whatever is in person.prototype, which is nice and simple. But additionally, we do more. We override describe, and because we put it into employee.prototype, this version of describe will be found before the version that comes with person. And the first thing we do is we call the overridden method, and then we add our own little bit of information afterwards here. And to call the overridden method, to make this super call, unfortunately, JavaScript doesn't have a built-in mechanism for doing that yet. So we have to do it by hand, and we directly refer to the method describe of person that's inside person.prototype. And we call it, and again, we use the current instance so that describe operates on an instance of employee. Let's look at that in action. So this is both, this up here is the superconstructor. This down here is the subconstructor, as we've just seen. And maybe, well, let's initially create an object to see how everything works. And then Jane now has a name. and title. And the properties in the object are name and title, because person has added the property name, and employee has added the property title. Additionally, let's try out say hello to. And here we can see that this inherited method, this method is 100% a method of person, and this inherited method works as it should. So it uses this dot name, and it says hello to the parameter. And if we use chain describe, it should return a string that now has title. So here we can see that person.prototype.describe, so the describe of person, contributed person named Jane, and the overriding method contributed the CTO afterwards. And now, now the structure is a bit more complicated, and you have the newly created constructor employee that has an instance prototype, and we can see the inheritance in two places. On one hand, employee calls person in order to set up the instance data properly. On the other hand, employee.prototype has person.prototype as a prototype. Okay, a lot of prototypes in there, but the diagram should make it clear. This object down here has a prototype, and that is person.prototype. And then you see that if you what makes it a little bit easier to understand is if you, for a moment, completely ignore the left column. And then what you simply have, if you look at Jane, is a prototype chain that has several elements. So the first element in the prototype chain of Jane is the instance with two properties. The next element of the chain is employee.prototype with the method describe, the method that the overriding method. The next member is person.prototype. This is the overridden method, and a method we inherit, say hello to. And then the prototype chain continues with object.prototype. So the inheritance actually goes further, and the object.prototype, those are standard methods that all objects usually automatically inherit. And if you look at built-in objects and instances of built-in constructors, then you can see that the way of handling inheritance of creating subconstructors is the same as we've just seen. So the language already comes with object and array, two constructors, and array is a subconstructor of object. And if you look at, if you create an array by this literal notation, then you you are, in fact, creating a prototype chain similar to what we've just seen with instance data, and those are the array elements and lanes. And that chain continues with array.prototype, and then again continues with object.prototype. And after object.prototype, the chain ends because the prototype of object.prototype is null. This is where the chain ends. And you can actually explore that in another example. So now we have an array stored in R, and we can examine the keys of it, and we see that the array indices are in here, length is hidden, but that doesn't matter now. And then we can, by the shortcut, we figure out the prototype of array, and we see that it is array.prototype, and array is also an instance of array. But array is also an instance of object. So under the hood, this kind of literal notation has invoked the constructor. And if we examine the prototype of the prototype, then it is object.prototype. And if we get the prototype of the prototype, now we're trying to access the prototype of object.prototype, and this is null because the prototype chain ends after object.prototype. And what we can do now is we can even add a method foo here, and that means it's available in arrays because object.prototype is in the prototype chain of all arrays, and therefore this one too. All right, let's conclude. Let's summarize the layers. And layer 1 was objects. Those are the basic building blocks of object-oriented programming in JavaScript. Layer 2 was prototype chains, and those are used for sharing properties or eliminating redundancy. The third layer was constructors, and those are used to set up instances as a factory for objects. There is, or what I always like to keep in mind when it comes to constructors is that there is separation of concerns. The function itself sets up the instance data, and the methods are put into the prototype property of the constructor. And that separation of concerns also matters whenever you derive a constructor sub from a constructor super. And there again, you have to first inherit the instance data by calling the superconstructor as a function, and then you have to inherit the methods by making super.prototype a prototype of shop.prototype. And as I said, constructors already get you pretty far. Inheritance between constructors is not necessary as often. Mixins are also quite popular, which complement constructors and are another way of doing inheritance that is often nicer than doing constructor inheritance. And thankfully, in the future, things will become easier, and especially layer number 4, inheritance between constructors will become easier because ECMAScript 6 has classes. And classes make the setting up of a subconstructor a lot easier, and they also make supercalls much, much easier. So that's been it from my part. The kind of the occasion for the webcast is that my new book will soon come out. It'll be available in March. And the book is called Speaking JavaScript. It has this nice bird on the cover. You can find information about it on speakingjs.com. You can also subscribe to be notified when the free online version comes out. And it'll be an HTML version of the book will be free to read online. So that's been it, and now I'm ready for questions.
Excellent webcast, Axel. Thank you so much for that. We have many questions that have come in. So, folks, we're going to take as many as we have time for, and we'll start just in the order they came in. So we have a question here that's asking, what impact does lack of type checking have on OOP in JavaScript?
All right. Impact. Yeah. There are two impacts. And with type checking, there's several areas where you could do type checking. So one thing is static type checking, where you say you have a programming language such as Java or C#, where everything is statically typed. So the kind of the interpreter or the knows at compile time what type everything has. And one advantage of that is that you can, that if you use an IDE, if you use an integrated development environment, you get nicer functionality. So if you have an object and type a dot, then you get suggestions, and traditionally these suggestions in JavaScript IDEs have been pretty bad. So you've had often like almost every DOM method. And if a program is statically typed, then you get a lot better suggestions. But the thing is that on one hand, and ECMAScript 6 will certainly help because there's a standard way of doing constructor inheritance. IDEs will get better at inferring types, so they will get better with helping you whenever you type a dot and want suggestions for methods. On the other hand, you also have the option to use TypeScript, which is basically ECMAScript 6 compiled to current JavaScript, and additionally you can you have optional type annotations. And those type annotations don't exist at runtime. They only exist statically, well, you could say at compile time and in the IDE. And that helps, that makes helps IDEs with giving better suggestions. So that's the advantages of static typing, of static type checking when it comes to IDEs. On the other hand, you can also compile programs faster. But the thing is that JavaScript engines have become really good at inferring types at runtime, and in V8 they're called hidden classes. So you can search online for the term hidden classes if you want to find out more. So under the hood, if you don't go overboard, or if you don't add properties after you've created an object, then V8 and other JavaScript engines have gotten pretty good at giving you the speed advantages of a statically typed programming language. Okay, that'd be my answer.
Thank you. A few more questions here, and folks, we'll take as many as we have time for today. Let's see here. Icaro would like to know, is it possible to have 2 or more prototypes for one object?
Very good question. Okay, short answer, no. The self, which is kind of the language that inspired JavaScript's prototypal inheritance, allows one to do that. You can kind of work around that limitation via mixins. So it's spelled, hang on. So the way this is spelled is mixin. You can search for that word, maybe search for JavaScript as well. And mixins give you multiple inheritance, but you still get a linear prototype chain. So the prototype chain does not become a tree, which has advantages. Okay, that's the answer.
Perfect. Okay, a few people asking about the prototype object question. So what's the difference between employee.prototype equals object.create? Person.prototype and employee.prototype equals person.prototype. And I hope I'm doing this correctly here.
Could you copy-paste the thing that has been written?
Yes. All right, I'm putting it right here for you, Axel. Here it comes.
Cool. Okay, let me see. Oh, shit. Q&A. Yes. Employee.prototype is, and employee.prototype. Yeah. All right, that's a very good question. What you would do is, initially it would work really nicely. And let's refer back to the slide. I like the question. So initially it will work really nicely because what you would have here, what employee.prototype would point to, would be the object up here. So as long as employee doesn't add its own method described down here, everything is fine because you get all of the methods of person.prototype, right? But as soon as employee add its own method, it could be compute salary, it could be other stuff. as soon as you do that, you add those to person.prototype 2 because you've just assigned that object to employee.prototype. And the prototype relationship that we have set up here allows you kind of to add an increment to person.prototype without changing the original. So it's kind of a non-destructive way of changing person.prototype. And that's why you use object create person.prototype and don't assign it directly. Okay.
All right. Next question here. This one is from Nandu. Are prototype chains similar to abstract classes in other programming languages?
Very much so, yes. There's an interesting paper called Organizing Programs Without Classes. And the organizing principles between classes and, well, JavaScript style or prototypal inheritance are very, very similar. And the main difference is that in class-based languages, and as an aside, even in ECMAScript 6, JavaScript will not be a class-based language because you have classes, but those are simply, but what those classes are translated to is constructors. So classes in ECMAScript 6 are syntactic sugar for constructors. And coming back to class-based languages, which and JavaScript will never be one. In those languages, you have two relationships for organizing entities. And you have two kinds of entities, too. You have classes and you have objects. And you have the subclass relationship and the instance of relationship. So the subclass relationship is between two classes, and the instance of relationship is between an instance and a class. And with JavaScript, there are only objects. And the only relationship you have, as you can see here, is the prototype relationship. So in class-based languages, this would be a class. This would be a subclass of relationship. This would be a class too. And in JavaScript, everything is an object, at least here, in this context. And there is only the prototype relationship. But the organizing principles are exactly the same. And with abstract classes, you're kind of thinking how to best group instances and or classes, and the same kind of thinking goes into constructor hierarchies when you design them in JavaScript. And you probably be using mixins more, but still, the thinking is very, very similar. Okay, thank you.
Okay, and we'll take our final question here. Axel, I'm going to put it for you in the same area. And this question is from Andrew, and he would like to know if you can describe again the advantages of using prototype style outside of the object on slide 17 versus the standard constructor on slide 15.
Yes, I can, sure. All right, let's go back to slide 15. So this looks simple, right? All you have is this function. You invoke it via the new operator, easy to understand, not very complicated. This is a method. This is a data property. And we're fine. Why make it more complicated? So that is the question. And the reason to make it more complicated is that the method described is in each instance. And we don't want that. So down here, we're putting the method described in each instance. And that is overhead. That is wasted memory. What we want to do is we want to share that method between all instances. And if you look at, so this is the standard constructor. This is the standard pattern. And here is only what is unique for each instance. And in this object, you put everything that is the same for all objects that should be shared. And then you have an advantage. This is what instances look like now. And you see that you could have 1,000 instances down here. You could have 1,000 persons down here. And they would all share the same single prototype and the same single version of describe. And the first kind of simpler version of the constructor would have put describing each of those objects, resulting in wasted memory. And an additional advantage of this pattern is under the hood, because engines are kind of used to that pattern, and usually it runs faster. Okay. Thank you.
Thank you so much, Axel. And with that, folks, we are going to say a very big thank you to Dr. Rauschmeier for presenting a really outstanding webcast for us all today and all of his live examples. And really, Doctor, for sharing all your knowledge and expertise with us.
Yeah, thanks for having me.
Attendees who attended our webcast today, we thank you for spending time with us and for participating in the webcast. And a big thank you to those of you that sent in your questions, because having your questions really adds so much to our events, and we thank you for that. We'd like to let you know as we close out here, please, if you didn't open your group chat, please open it before you leave. There's some great information there that can save you some money. And with that, we mean Axel's book. He's got a great book coming out, should be released next month. We have a code in there so you can pre-order it and save some money, because if you like what he talked about today and what he showed you, there is so much more in that book that can really help you with your day-to-day. So we invite you to take advantage of that discount. As well, next month, O'Reilly has our Fluent Conference happening in San Francisco, California, March 11th through the 13th, and I hear we may still have some tickets. Use code WEBCAST. Write that down, WEBCAST, and you can save 20% on tickets if you're in the area. Dr. Rauschmeier will be speaking there live, and you can meet him in person, shake his hand, say hello. Just imagine what he's going to talk about and show you there. So again, write that down, code WEBCAST, to save 20% on the tickets.